I'm Josh.
And we are presenting on Microstegium viminium or Japanese stiltgrass. And so we're going to get started by showing our spotlight videos. Mabuhay, Sambutan, welcome. Today, I want to talk to you about stiltgrass. Latin name, Microstegium viminium. Right here, you can see the specimen itself. This defining characteristic of this leaf right here comes out this main stalk, and the fruiting body's up there. So, Japanese stiltgrass was used for packing in containers in the 19th and 20th centuries, and that's how it got introduced. It also spreads through disturbances caused by things like this log skidder right here. The tires, the blade, the dragging of logs behind it all create disturbances so the grass over here can flourish. Big patch right here. Also called Nepalese brown pop. As you can see, it's starting to brown out. It's reaching about its max height, about 3 feet or 1 meter. So, the reason it causes a problem is over here, as you can see, it creates almost a carpet-like area where it creates and shades out all other competing species. Over here, it's forming up. There's nothing growing on this bank except for stiltgrass. It shades out all the competition. And the worst part about it is it has a 5 to 7 year seed bank. So even if you cut it with mechanical controls, it'll come back the next year. You have to do a 7-year treatment to get it to stay going. And that's why you want to prevent it. Places like the National Forest have rules where if you're going to do harvesting operations, timber harvesting operations, you have to create as little disturbance as possible. Prevent it from spreading. All right, and now we'll show Josh's video. Mabuhay.
This is Japanese stiltgrass. It is growing in a disturbed forest edge behind the apartment buildings, and it's growing in other patches in the openings of the canopy over there as it spreads. It has lance-shaped leaves that are 1 to 3 inches long. The common name is Japanese stiltgrass, and the Latin name is Microstegium viminium. This is what it looks like.
All right, so the species history. Japanese stiltgrass, as you would guess, it's native to Japan, but it's also native to other parts of Asia, like China, Korea, Malaysia, India, and the Caucasus Mountain region. It was likely introduced to the eastern U.S. in packing materials. Specifically, they assume from fine Chinese porcelain. And that was by, I think her name's Mrs. Fryer. She's like an expert on stiltgrass. And it spread from there. It was pretty common to use random junk grass as packing material. You want to do the next one?
Yeah. So some of the control methods are mechanical controls, which consists of regular mowing intervals. Chemical control methods consisting of foliar spray as pre-emergent treatments. I did some of the foliar spraying this summer, and it definitely worked well. Within 2 days, it was completely dead, but that was a multi-year spraying contract, so it would come back the next year as well. Cultural methods such as prescribed burning work as well. And the most effective is a multifaceted approach using both chemical and cultural techniques.
These are pictures of stiltgrass. The one on the left is there in a field, and that's actually a screenshot from my video.
But as you can see, it has those distinctive leaves coming off the sides of the main stem. It's grass, but it almost looks like an umbrella that's broken, like how it's coming off. Yeah.
So some ecosystem interactions, it increases the soil pH and phosphorus, which can reduce the potential diversity of the soil. It can also accelerate the carbon cycle and reduce the succession rate due to the dense mats it creates everywhere.
This is our concept map. As you can see, it shades out the new regeneration, like Josh was saying. It just forms such thick patches that nothing can grow and compete with it. It's naturally dispersed by flooding and wind. And then human-caused disturbances also create the ideal area for it to establish. Grasshoppers, crickets, and katydids all graze on it. Those are all insects. And the soil interactions we found these are also, according to Fryer, are higher moisture, higher phosphorus, higher potassium. It raises the pH and it lowers ammonium levels, which is really interesting. Normally, invasive plants are nitrogen fixers. And here are our references. Do you guys have any questions? Do you guys have any questions?
Questions?